तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करने वाले हैं। इसमें क्या दिया है, इन एन एक्सपेरिमेंट टू डिटरमाइन द एक्सेलरेशन ड्यू टू ग्रेविटी g, the formula used for the time period of a periodic motion is t is equal to 2 pi under root of 7 r minus r divided by 5g. The value of r and r are measured to be, so this is for the capital R and this is for the small r. So you can see that they have given the absolute errors for the capital R as well as small r. In five successive measurements, the time period is found to be. So they have got these values for the time periods. They have made the five observations. The least count of the watch used for the measurement of the time period is 0.01 second. Which of the following statements are true? So first statement is error in the measurement of small r is 10%. So small r is this value. So to calculate the percentage error in the measurement of r, we have to use this formula delta r divided by r into 100%. So delta R is absolute error in the measurement of R, and that is given as 1 mm, and the value of R is given as 10 mm. Okay, that is the measured value. So we can calculate this percentage error as 1 divided by 10 into 100. That is 10%. So the first statement is correct. Let us look at the next one. The error in the measurement of T is 3.5%, 3.57% or 2%. So these both these options we need to find out the error in the measurement of t. So to find the error in the measurement of t, we will have to consider these observations. Okay, they have given these five observations, and based upon that, we can calculate the percentage error in the measurement of t. So basically, what we have to find is delta t divided by t into 100%. That is the percentage error in measurement of t. So before that we will have to calculate mean value of the time period, and that is calculated by considering all the observations. So basically we have to take the sum of all these time periods and divide it by number of observations, that is 5. So if you calculate that, you will get answer as 0.556, which is approximately equal to 0.56. The next thing that we have to do is we have to calculate the absolute errors in each observation, and that is calculated by this formula. So we have to do this for each observation. So this 0.56, this is gonna be constant in each calculation, okay? Because that is the mean value of the time period. So basically we are subtracting each measurement from that mean value of t. So when we subtract, what we get is absolute errors, okay? And we have to consider the magnitude of that, okay? Modulus, we have to consider the modulus. Once we calculate those values, we can take the mean absolute error as 0.04. So these values, whatever we calculated, and then we have to take the sum of that and then again divide by the number of observations. So it comes out to be 0.02. So that will be the mean absolute error. And then to calculate this delta t by d, we have to consider this mean absolute error and divide it by mean value of time period, and then multiply by 100. So if you calculate that, it comes out to be 3.57%. Option B is correct. Option C is incorrect. Okay. Finally, they have asked about the error in the determined value of G. So we have to calculate how much error will be in the G, percentage error. So the formula that they have given is T is equal to 2 pi under root of 7 R minus R divided by 5G. So this is the formula they have given, and we have to calculate the error in determining the G. So basically we have to restructure this equation in terms of G. So basically we have to take the square of both sides. After that, G will be taken to the left side, and then T square will be moved to the other side. So equation will become G is equal to 4 pi square divided by T square into 7 R minus R divided by 5. So if you solve this further, we will get 28 pi square divided by 5 into R minus R divided by T square. Now once we get this equation for G, then it is very easy to calculate the percentage error in G, which is represented as delta G divided by G into 100, which is equals to Now in this equation, this is a constant part, so we can ignore that, okay, because it is not going to impact the error. So only we have got two terms, numerator and denominator. So since we are subtracting here r minus r, basically we have to take here delta r plus delta r, okay. We have to add those absolute errors in the measurement of capital R and small r divided by r minus r, okay. Plus, since we are dividing it by t square, we have to add this plus over here. Then 2, since this is the t is raised to power 2, we have to take 2 over here, and then it will be delta t by t and into 100. So over here I have multiplied by 100 to both the terms. Delta r and delta small r, both values are 1, okay. So 1 plus 1 divided by capital R value is also given and small r value is also given, 60 and 10. So we can easily calculate this one. Then 2 into delta t divided by t into 100. So this value we have already calculated above, which is 3.57. And then putting these values, what we get is 4 plus 7.14. And finally we get percentage error in G as 11.14%. So that will be the answer for the last option. The error in the determined value of G is 11%. So which is approximately 11%. So the D is also correct option. Thanks for watching.